Here we're given a function, and we want to determine if it has an inverse, and if so, we want to find a formula for the inverse. Now, if there is a formula for the inverse, that would actually show that f has an inverse. So you could actually just answer the second part, and that would answer also the first part. But I'll show you the first part without trying to find a formula. So if a function is gonna have an inverse if it's 1-to-1. So when it's 1-to-1, you can revert the roles of the input and the output. Okay. Once again, the reason is that when it's 1-to-1, you don't have two arrows in the domain going to the same place in the range. Because if that's the case, you could not revert the sign of the arrows to create a new function, because right, we know that we cannot have something in the domain associated to two different things in the range, so that wouldn't be a function. But when it's 1-to-1, you always have like one arrow arriving to a unique place on the other side. This way you can actually revert the sign of the arrows, okay, and create a new function, which is going to be your inverse function, where the domain of the inverse is going to be the range of the initial one. So we have to determine if it's 1-to-1. So is f a 1-to-1 function? And for this, maybe we can rely on the graph, okay, of f. So if we graph y equals 2x plus 1, this is actually a line, right, with a y-intercept of 1. So if we look at the horizontal lines, they intersect the graph in only one place, which makes the function a 1-to-1 function. So since horizontal lines intersect, this is the horizontal line test, right? Intersect the graph of f in only one place, this is a 1-to-1 function. So which means there's an inverse. Okay. So what's the inverse? Okay. Right now we've got y as a function of x, but we actually want to revert that. We want to have x as a function of y. So the question is, given y, what is x? Okay, so given y, what is x? We want to write x as a function of y. In other words, to find the inverse function, solve for x. So we're going to do this. So we're going to subtract 1 and divide by 2. And usually if I'd like to have my x on the other side, so I'm going to flip things around. And that gives me x as a function of y. So I could write x is f minus 1 of y. That's my inverse function, which is 1/2 y minus 1. Okay. But usually we like to have our functions written so that the input is called x. So we're going to rename this. Okay. Okay. So if I just focus on what I just framed, I'm just going to replace y by x. Right. I could replace it by input, of course, if I want to. I can write f minus 1 of input is 1/2 of the input minus 1. But we like to have our input written as x. So this is usually how we're going to write down our formula, just like that. So we solve the equation for x. That gives us a function of y. That's called the inverse function. And then we could just replace y by x. Okay. Solution 2 here. So I know that when I was in high school, this is how they taught me. You've got your equation like this. Okay. The solution 2 would be change the roles of x and y. So in other words, call now x is going to be the previous the output and y the input, right? So I'm changing the roles of domain and range essentially, and then you solve for y. So that's another way of approaching the problem. So see, if I solve for y, I'm going to get 1/2 x minus 1 is y. So now y is really my inverse. So you see the, if I write it like that, it's okay. So if you look at what I have here and what I have here, those are the same. So you could write, so therefore f minus 1 of x is 1/2 x minus 1. So you can do it any way you want to. So this is solution 1, solution 2. Okay, and just to remind you, for example, if you've got 3 and you apply f to that, okay, what are you going to get? So let's remind ourselves, y is, so f of x is, I'll write it here, f of x is 2x plus 1. So we get 2 times 3 plus 1, we get 7. F inverse of x is 1/2 x minus 1. So if we do f inverse of that, okay, if I do f inverse of 7, I get 1/2 7 minus 1. So I get 1/2 of 6, I get 3. So of course I'm back to where I started. So this is what I was telling you before. If you do f minus 1 of f of 3 or f of x in general, you're going to get back what you had. So f of f minus, and so in general, f minus 1 of f of x will give you x. If you do f of f minus 1 of x, you'll also get back what you had, x, because you're kind of looping around. Okay, and in terms of I want to show you how the graphs are connected. That's the last part. So how are the graphs of f and its inverse connected, or related? Maybe related is better. Okay, well, let's take a look. Let's again write down the equations. One is, so f of x is 2x plus 1. So I'm going to try to be a little more precise here. Like that. That's 2x plus 1. So slope of 2 at y-intercept of 1. Like this. Okay, this is f. And the other one is, what is it? It's f inverse is 1/2 x minus 1. Maybe I'll expand it to have it in slope-intercept form. So now it's a slope of 1/2. Notice how the slope now is the reciprocal of the previous slope. Maybe this is not a coincidence. Now slope is 1/2 and y-intercept of minus 1/2. So if this is minus 1, we're going to cross here, and a slope of 2 means if I go forward by 2, I go up by 1, so I'm going to end up there. So I'm going to have something like this. Yep. Okay, so this is f inverse right here with a slope of 1/2. Okay, if I take a point, for example, what do I have here? If I take, for example, the value at 2. So at 2, the function value is 5. Okay, well, right, 2 gets sent onto 5 through f. Well, if I take the 5 and apply it to f inverse, I'm going to go back to where I started, right? So if 2, 5 is on the graph of f, while 5, 2, so you flip around the coordinates, is on the graph of f inverse. So if I go at 5, 2 would be probably somewhere here. Okay, like that. If I take this one, this one's interesting. If I take the y-intercept, okay, 0, 1, okay, now replace 2 by 0, the image by 1, so 0 gets sent onto 1, 1 gets sent on 0, so now it's 1, 0. That's part of the graph of the inverse. So you see, any point that's on the graph of f is, if you revert the coordinates, it's going to be a point on the graph of the inverse function. And this is what's interesting to see is if I draw the line y equals x, okay, normally if I did my job correctly, f inverse, okay, is going to be so the graph of f inverse is going to be a reflection of the graph of f across the line y equals x. This is what happens when you if you invert coordinates, you're basically reflecting across the line y equals x. This kind of makes sense because you see on the line y equals x, y and x are the same. So if you revert the coordinates, you stay where you are. Okay? So this is why it's the axis of symmetry. On the axis of symmetry, things stay where they are. But if you're elsewhere, so in the curve on the curve for f, if you flip around the coordinates, you're going to reflect with respect to the green line, and therefore get the blue line. So this is also why the slopes are reverted, right? So on the slope of f, it's delta y over delta x, and it's essentially 2 over 1. But now when you look at the slope of f inverse, okay, then it's the rows of x and y have been interchanged, okay? So now it's going to be 1 over 2, okay? So you see why the slope is now the reciprocal of the previous one. So this is always what happens. So in a nutshell, if I give you a function, okay, that's 1 to 1, for which you can calculate the inverse. So I don't know, something like this, a bit funky like that, okay? If you want to calculate the graph of its inverse, or not calculate, but actually sketch the graph of its inverse, you draw the line y equals x, and then you reflect it across that line. So roughly it would be something like this, you see? Roughly, okay? That would be the graph of the inverse. It's just a reflection. So maybe let's write that down. So the graph of f inverse is a reflection across the line y equals x of the graph of f. If x0, y0 is on the graph of f, then y0, x0 is on the graph of the inverse. So what I mean by this is if you've got x0, y0 here, okay, across that line, you'll generate the point y0, x0, and which is going to be part of the graph of the inverse.